All right, so we are learning 14.1 in pre-calc now. Chapter 14 is all about an introduction to calculus. We're going to be focusing particularly on limits and derivatives. Today we're just going to kind of get an introductory lesson on what is a limit. So the idea of a limit of a function is what connects algebra and geometry to the mathematics of calculus. In working with the limit of a function, we encounter this notation. So you're going to see this a lot. Now that is read as the limit of the function f as x is approaching c is equal to some number. So the limit as x is approaching c of this function is equal to some number. Think of this guy, think of c as the x value of a function and n is the y value of a function. So it's saying as x is going to c, the x value, what is the y value? Now in order for a limit to exist, the function must approach the same number from the left and the right hand side of c. If the function approaches a different number, then we say that the limit does not exist. Okay, so we need it to approach the same number. If it doesn't approach the same number, then we say the limit does not exist. So for example, to give you some ideas, if we have the limit as x is approaching c of f of x, so as we're getting closer to c, so from this side as I get closer to c, from this side as we get closer to c, the y value we get closest to here is n. Right? So if that was 2, then the answer would be 2. As we get closer to c, well, what are my arrows pointing at? My arrows are pointing at, once again, this y value of n. I know we have this dot up here, which makes it seem like this would be our answer, but we don't care what happens right here. We're saying along the curve, as we get closer and closer, what number are we getting closer and closer to? Okay, so even though there's a hole, even though they have this dot up here, we're looking along the curve. Okay, same thing here. As we get closer and closer to this c value, right? As we get closer and closer to this value here, we get closer and closer to this n value. Okay, so the thing to keep in mind with limits is that we don't care what happens at c, but rather what happens as we get close to c. Right, so I don't care that at c this is a hole. We're not going to say that's undefined. Actually, we're not even going to use the word undefined in this whole section. Okay, we're not going to say this is undefined. We don't care that right here there's a hole. We just care as we get really close, it's close to the number n. Okay, so we don't really care that it's a hole because we don't care what happens at c. Now remember we said if it approaches a different number from each side, then we say the limit does not exist. So for some examples here, if we were getting the limit as x is approaching 1 of f of x, well, as we get closer and closer to this 1 here, this number is 1, but as I get closer and closer from this side, the y value is 2. Well, 1 is not the same as 2, so we say the limit does not exist. Okay, same thing here. If we were getting closer and closer and closer to 1, on this side the number is 2, but on this side we're getting closer and closer to 4. Well, 2 is not the same as 4, so we would say does not exist. Okay, so that's the whole idea of limits, is that we need them to approach the same number from each side. As our arrows, as our graph is coming closer and closer together, they need to be the same number. If it does this, these aren't the same number, then we say it does not exist. Okay, now in this section, we're going to be looking at two different ways that we can approach limits. Okay, we can look at it graphically, which is kind of what we were doing above. So for example, if I gave you a graph that looked like this, and I said find the limit as x goes to 2, we would say that answer is 4, right? As we're getting closer and closer to 2, the y value is 4. Now we could also do this in tables. So in tables, what this would look like is that, okay, we're getting closer and closer to 2, so we're going to look at numbers really, really close to 2. So for example, a number that's less than 2 but really, really, really close to 2 would be 1.999. It's not 2, but it's really close to 2. Another number that's really close to 2 is 1.99. It's a little closer to 0, but it's still very close to 2. On the bigger side, we've got 2.001. That's just a little bit bigger than 2. 2.01 is a little bit bigger than 2.001. Right? And then in our calculators, we would look to see what these values are, and we would get numbers, for example, like this. Right? And we're like, well, what's going on here, right? There's an error. Now keep in mind, we don't care if it's undefined. So this graph kind of looks like this guy, right? So these two are the same. At 2, I don't care that there's a hole here, that it's undefined. That doesn't matter because we don't care what happens at C. We say, well, what's happening as we get closer and closer? So as we get closer and closer to 2, as we get closer and closer to 2, we're getting closer and closer to the number 4. Okay, so let's look at some examples. So in our first page here, it wants us to use a table to find the indicated limit for each. So this one is saying find the limit as x is approaching 1 of negative 9x squared. So we're going to make a table. And our limit here is we're approaching 1. So that's the number that we're approaching. That's the number we're going to put in the middle of our table. And then we're going to pick numbers to the left and right of 1. Well, a number a little bit smaller than 1 would be 0.999. Even smaller would be 0.99. A little bigger than that. Okay, so now that we have this table, we're going to go to our calculators and we're going to input this into y equals. Okay, so step 1, plug the function into y equals negative 9x squared. Now we also need to make sure that we change our table set. So maybe I'll down here write our steps down. Step 1, plug into y1. Change table set. So remember when we had that, when we were doing it earlier in the year, we had independent and dependent, and it has auto, ask. We want our independent to be ask, and we want the dependent to be auto. So in order to do that, we're going to go to our table set, which is second window, and we're going to change the independent to ask. Oops, I messed up. Doesn't matter what these numbers are, just make sure it changes to ask. So now what we're going to do is we're going to go to our table and we're going to plug these numbers in. So 0.99, oops, I messed up, 0.99, 0.999, 1, 1.001, 1.01. Okay, so we have these numbers. Right, so as we're getting closer and closer to 1, right, as we're getting closer and closer to 1, these numbers keep getting bigger towards -9. These numbers keep getting smaller and they're moving towards -9. So our answer here is -9. Okay, so step 1, plug it into Y1. Make sure you change this. Step 3, input values into table. Okay, so I'm going to skip number 2 for a minute. We're going to look at number 3. So number 3 says the limit as x is approaching -2. So -2 here is what's going to be in the middle of our table because that's what we're approaching. So a little bit smaller than -2 would be -1.999, and then -1.99, a little bigger. Okay, then we're going to plug it into y equals. We already changed our table set, so we can just go straight to our table and we're going to plug in our values here. So now keep in mind, when we go to find our answer here, we don't care that there's an error. We're looking at, as we're getting closer and closer, what's happening. Well, these numbers are getting closer and closer to -2. Okay. Now, because all of our work here is going to be on Math Excel and such, if you don't write all of these down, that's fine. So for example, I'm going to look at number 6 here. So in number 6, if we made a table, it says x is approaching 1. I'm going to go into y equals, change our graph. Go to our table, change our values. Now, I'm not going to require you to fill these in. If you can look here and say, oh, Miss Peck, I can tell this is getting closer and closer to the number 5, then that's totally fine. You can just skip to that point. I just wanted to show you in the first couple on paper, but if you can just plug them in here. I personally probably, if I were you, I would make this table and not do the y values. Like, there's really no point for me to copy these y values down. Now in calculus next year when you do these problems, you will have to do that, but because you're not turning in any hard paper to me right now, that's fine. But it's nice in my brain at least to write these down so that I know which numbers I'm plugging in. But then once I plug them in, I'm just going to look here and say, well, what are we getting closer to? And that answer is 5. Okay. I will say with number 5, you have to make sure you're in radian mode for number 5. So make sure you get put in radian mode for number 5. I'm going to leave number 5 and number 4 for you guys to try on your own. But for number 2, what we got going here is a piecewise function. So we have that we want to find the limit as x is approaching 0, but we have 2 different functions. The first function is for when x is less than 0. The second function here is when x is greater than or equal to 0. So we have this really cool thing on our calculator that we can actually do this. So we're going to create our table. X is approaching 0, so 0 is going to go in the middle here. A number a little bit bigger than 0 would be 0.001. A little bit bigger, 0.01. A little bit smaller would be this. Okay, now when doing these, we're going to have to do two functions in our calculator. So we're going to have to plug into y1 and we're going to have to plug into y2. So what we're going to do is we're going to take our function and we're going to make fractions here. Now in y1, the top of our fraction is going to be x minus 1. The bottom of our fraction is going to be x is less than 0. For y2, the top is going to be 3x minus 1. The bottom is going to be x is greater than or equal to 1, or to 0, sorry. So that's exactly what we're going to do on our calculators. So I'm going to go to our y equals here, make a fraction. On the top is going to be x minus 1. On the bottom is going to be x is less than 0. Now to get these symbols, we're going to do second math to get those symbols. So we're going to go second math. And it's less than 0. And then in y2, we're going to make a fraction, 3x minus 1. And then x is second math greater than or equal to 0. Now what's really cool is that, for example, if we were to graph this, it does the piecewise for us, right? So this is x minus 1 until we get to 0, and then when we get to 0, it changes to 3x minus 1. So now let's go to our table and see what that looks like. Well, we have, let's plug in our numbers. So 0.01, oops, put too many decimal places in there. Negative 0.001, 0. 0.001, 0.01. And it even tells us errors here. So at this point, our answer is negative 1.01. But then at the next one, it's negative 1.001. At 0 here, at 0, it's error, but if you look here, it's negative 1. So now we're going to go to this column and copy down these numbers. So negative 1, negative 0.997, and then negative 0.97. Okay, so as we're getting closer and closer here, we're getting closer and closer to negative 1. Okay, so I want you guys to try 4 and 5 on your own, and then check your answers.